So, an alternate source for static pressure is provided in some airplanes in the event the static ports become blocked. This source usually is vented to the pressure inside the cockpit. Because of the Venturi effect of the flow of air over the cockpit, this alternate static pressure is usually lower than the pressure provided by the normal static air source. So you'll be having alternate source for the static pressure. I think you all know the what is static pressure. The pressure which will be present in all time. Okay. Um, this will be required in some airplanes. What will happen? You will be placing this extra, that is alternate source, in the cockpit, inside the cockpit, so that which will be the static pressure, alternate static pressure will be always lower than your normal static air source. Okay. So when the alternate static source is used, the following difference in the instrument indication usually occur. So alternate static source use பண்ணீங்கன்னா you have to modify some indication in the instrument. Okay. So the altimeter will indicate higher than the actual altitude. Okay. So altimeter is used for measuring the height height of the aircraft system from the ground. So this altitude will be measured differently. Okay, somewhat greater than the actual altitude it will be measured. அதே மாதிரி ஏர் ஸ்பீட் indicator will show the actual air speed. So when you are using the alternate source, static source, then it will be somewhat higher than actual. Okay. So consult the airplane flight manual or pilot's operating handbook to determine the amount of error. So they will be using the manual or a handbook for determining the amount of error occurring due to the um, alternate static source. If the airplane is not equipped with an alternate static source, breaking the glass seal of the vertical speed indicator allows ambient air pressure to enter the static system. This makes the VSI unusable. So, if you are in some other plane, they will not be using any alternate static source. In that case, you will be using vertical speed indicator in which the glass cell may be broken to get your static pressure. Okay. So now we are going to see about the altimeter. This is your altimeter. Okay. So altimeter measures the height of the airplane above a given pressure level. Since it is the only instrument that gives altitude information, the altimeter is one of the most vital instrument in the airplane. To use the altimeter effectively, its operation and how atmospheric pressure and temperature effect is, it must be thoroughly understood. A stack of sealed aneroid wafer comprises the main component of the altimeter. See here. So this is your altimeter which going to measure the height of your airplane with a given pressure level. So this is the only instrument in the airplane which will be measuring the height of the airplane. So it's going to be play an important role in the device, in the airplane, and then by knowing the altimeter and then its operation and as well as pressure value, temperature value, we have to understand thoroughly about it. And then the main part of the altimeter is aneroid wafer. This one golden colorல இருக்கு இல்லையா, this is aneroid wafer which is the main component in the altimeter. So these wafer expand and contract. I think you all know what is expand and contract. So expand and contract means it will become small and large. Okay, this expand and contract with the changes in atmospheric pressure from the static source. So due to the changes in static source pressure value, the wafer may expand or contract. So the mechanical linkage translate these changes into pointer movement on the indicator. So based on this contraction and the expansion of wafer, you will be having a indication in the meter. Okay. So the needle will be connected to the wafer, so it will be showing the value, pointer will show the value based on the contraction and expansion of your wafer. Okay. So how it works? So the pressure altimeter is an aneroid barometer that measures the pressure of the atmosphere at the level where the altimeter is located and presents an altitude indication in feet. So based on the barometer, aneroid barometer, barometer is a device which will be measuring the atmospheric pressure, okay, to indicate your altitude value in terms of feet. Height will be determined in terms of feet. Then the altimeter uses static pressure as its source of operation. Static pressure going to be a source here, and then air is denser at sea level than aloft. So as the altitude increases, atmospheric pressure decreases. So air will be very dense at sea level, but in aloft mean other than seaport. Okay. um, the altitude value will be increasing, okay, but the pressure value will be decreasing. So this differences in pressure at various level causes the altimeter to indicate changes in altitude. So based on the uh, place or level, sea level or land level or um, space, it will be the pressure value will be changing, which will be indicating the different height levels. Okay, that is altitude level. So the presentation of altitude varies considerably between different types of altimeter. Some have one pointer while other have two or more. Only the multi-pointer type will be discussed in this handbook. So here we will be having the different altitude ranges. More than one pointer will be indicating the different uh, altitude. So the dial of a typical altimeter is graduated with numerals arranged clockwise from 0 to 9. Okay. Movement of the aneroid element is transmitted through the gates to the three hands that indicate altitude. The shortest hand indicate altitude in 10 of 1000 of feet, the intermediate hand in thousands of feet, and longest hand in hundreds of feet. So here you will be having three hands through gear, the aneroid element. That is that wafer will be connected to the needle, that is pointer. Okay, so the shortest hand will be indicating the altitude value in thousands value, 10,000s value. Okay, 30,000, 40,000, 50,000, like that it will be indicating the shortest hand. Then intermediate hand will be indicating the needle in thousands of feet. That means 1,000, 2,000, 3,000, like that. The longest hand will be indicating hundreds of feet, 200, 300, 400. So 200, 300, 400, hundreds of feet வந்து represent பண்றதுக்கு longest hand, thousands of feet represent பண்ண intermediate hand, 10,000 ரேஞ்சில் 10,000, 20,000, 30,000 அந்த ரேஞ்சில் indicate பண்ணுறதுக்கு shortest hand will be used. So totally three hands will be indicator used to indicate the altitude value. So the indicated altitude is correct, however, only when the sea level barometric pressure is standard, that is 29.92 inches of mercury. The sea level free air temperature is standard plus 15 degrees Celsius or 59 degree Fahrenheit. Okay, so in the level the altitude indicator is correct. Okay, and the pressure and temperature value goes on decreasing at a standard rate while you are increasing the altitude value. Okay, So on increase of altitude value, the pressure and temperature value will be goes on down. So adjustment for non-standard conditions are accomplished by setting the corrected pressure into a barometric scale located on the face of the altimeter. So if you want to adjust the non-standard value, there is this is standard value. These two at sea level as well as in the at sea level pressure and temperature value is given here. This is standard one. If you want to get alter the value, then you have to correct the barometric scale. Okay. The next effect of non-standard pressure and temperature. So standard pressure temperature la இருக்கிறப்ப you will be getting the correct altitude value. If it is not fixed, okay, non-standardா இருக்கு, இந்த ரேஞ்சில் இல்லை, டெம்பரேச்சரும் ப்ரெஷரும் இந்த ரேஞ்சில் இல்லை, அப்போ என்ன ஆகும்? Okay. So what will happen to your altitude? That is given in next paragraph. So if no means were provided for adjusting altimeters to non-standard pressure, flight could be hazardous. Okay. So it will if you are not getting the standard pressure and temperature, then your flight may enter into the dangerous. Okay. For example, if flying from a high pressure area to a low pressure area without adjusting the altimeter, the actual altitude of the airplane would be lower than the indicator altitude. And old saying, high to low, look out below, is a way of remembering which condition is dangerous. That means high pressure ஏரியாவிலேருந்து லோ ப்ரெஷர் ஏரியாவுக்கு உன்னோட ஃப்ளைட் மூவ் ஆகிறப்ப யூ ஹாவ் டு அட்ஜஸ்ட் த அல்டிமீட்டர் வேல்யூ. ஓகே. Unless it will be in the dangerous. Okay, enter into dangerous one. அதை தான் என்னன்னு சொல்லியிருக்காங்க, ஒரு ஸ்லோகன் மாதிரி சொல்லியிருக்காங்க, ஹை டு லோ லுக் அட் பிலோ. ஓகே, which will be indicating the dangerous sign. When flying from a low pressure area to a high pressure area without adjusting the altimeter, the actual altitude of the airplane is higher than the indicated altitude. So whenever you are moving from high pressure area to low pressure or low pressure to high pressure, you have to do the alteration in the altitude value. Okay. Unless you are doing, then it will be entering into the dangerous part. Okay. So high pressure area and the low pressure ஆகிறப்ப என்ன பண்ணும், யூ ஹாவ் டு சேஞ்ச் த ஆல்டிடியூட் வேல்யூ லோயர். ஓகே, ஆக்சுவல்லேருந்து லோயராக கொண்டு போகணும். அதே மாதிரி லோ ப்ரெஷர் ஏரியா டு ஹை ப்ரெஷர் ஏரியாவுக்கு போகிறப்ப யூ ஹாவ் டு அட்ஜஸ்ட் த அல்டிமீட்டர் வேல்யூ டு ஹையர் வேல்யூ. ஓகே. அதே மாதிரி வேரியேஷன் இன் டெம்பரேச்சர். இப்போ ப்ரெஷர் வேல்யூவில் வேரியேஷன் இருந்துச்சுன்னா you have to change the altitude value unless it will be entered into the dangerous one. அதே மாதிரி temperature, air temperature also will affect the altimeter. Okay. So on a warmy day, a given mass of air expand to a large volume than on a cold day. You all know warm day la pathina the air will be very heavy compared to your cold day. So rising the very heavy means the temperature in air will be very large compared to your cold day temperature. So which will be rising the pressure level. So the temperature will rise the pressure level, so that what will be happen? The altimeter will be changing. So for example, they given the pressure level where the altimeter indicates 5,000 feet is higher on a warmy day than under standard condition. So warm day la patina 5,000 feet will be indicated when your pressure level is high. Okay. But இதே cold day la patina the pressure value will be very low. So altimeter will be indicating lower than your 5,000 feet. Okay. Warm day la 5,000 feet விட அதிகமாக காமிக்கும் altitude. But ஒரு cold day la it will be indicating lower than your 5,000 feet altitude value in the altimeter indicator. Okay. So the adjustment to compensate for non-standard pressure does not compensate for non-standard temperature. So in pressure value la compensate பண்ற மாதிரி you cannot compensate on temperature non-standard value. So this is indicated the effects of non-standard temperature on an altimeter is indicated in the diagram. See here. So in the warm day la patina 30 degrees Celsius la the altitude value is above 5,000 feet. Okay, your aeroplane height will be very high on a cold day. Okay, so the altitude value will be very low. It is less than 5,000. Okay, this is your 5,000. Here you are getting somewhat 3,000 only in the cold weather condition. Okay, the pressure value will be changed due to change in temperature, air temperature. So, if terrain or obstacle clearance is a factor in selecting a cruising altitude, particularly at higher altitudes, remember to participate that a colder than standard temperature places the airplane lower than the altimeter indicates. Therefore, it is necessary to use a higher indicated altitude to provide adequate terrain clearance. Modify the memory aid to high to low or hot to cold. Look out below. So high to low pressure ஏரியாவுக்கு மூவ் பண்ணுறப்பையும் இல்லை ஹாட் டு கோல்டு வெதர் கண்டிஷன்ஸ்க்கு மூவ் பண்ணுறப்பவும் யூ ஹாவ் டு look out the altitude value which will be lowering. Okay, which will become lower compared to your standard value. Okay, so how you will be setting the value in altimeter? This is next part. So most altimeter equipments are equipped with a barometric pressure, which will be setting the window, that is Colesman window, which will provide a adjustment of altimeter. Here we will be using knob to locate the bottom of instrument for adjustment. So to adjust the altimeter for variation in atmospheric pressure, the pressure scale in the altimeter setting window calibrated in inches of mercury and millibars will be adjusting the altimeter setup. Okay, so the altimeter will be set up through the uh, setting window, barometric pressure setting window. Okay, this will be used for setting the adjustment. Okay, adjustment in the altimeter. So a knob will be placed in the bottom of your instrument, which will used for making adjustment. Here pressure scale will be provided in the altimeter, which will be indicating the alignment, that is changes. Okay, changes in the measurement. Okay, the needle change and the knob திருவ திருவ அந்த needle change ஆகும். Okay, so in this manner you will be doing the adjustment. So, altimeter setting is defined as station pressure reduced to sea level. However, an altimeter setting is accurate only in the vicinity of the reporting station. Therefore, the altimeter must be adjusted as the flight progresses from one station to the next. Many pilots confidently expect that the current altimeter setting will compensate for irregularities in atmospheric pressure at all altitudes. But this is not always true. So, some pilot may expect that the current altimeter setting will be compensated with the irregularities, that is, non standard value of the pressure value for all the altitude range. But it is not at all true. You have to change all the value in the altimeter based on the pressure and temperature changes. Okay, so the altimeter setting broadcast by ground station is the station pressure corrected to mean sea level. It does not account for the irregularities at a higher level, particularly the effect of non-standard temperature. However, if each pilot in a given area is using the same altimeter setting, each altimeter should be equally affected by temperature and pressure variation error, making it possible to maintain the desired vertical separation between the aircraft. So, from the ground station, they will be indicating the non-standard, that is altitude value will be sent to the each and every pilot in that particular area. But if the pilot maintains the same altimeter setting in the autopilot system, then what will happen, it will be enter into some error. It will, there may be a possible of getting the error value in the indicator, altimeter indicator. Okay. So when flying over high, that is mountainous terrain, certain atmospheric condition will be causing the altimeter to indicate the altitude value of 1000 feet or more than that. Okay, which will be the higher than your actual altitude value. So for this reason, generous margin will be allowed for indicating the altitude value, which will not create the altimeter error. Um but also for possible downdraft that might be associated with the high winds. So, height, mountain terrain, as well as in some bad weather conditions, move ஆகுறப்ப, the altimeter will be indicating the altitude value more than 1000 feet. Okay. So, இந்த மாதிரி cases you will be setting the margin value for altitude value, which will not giving the error in the altimeter indicator. Okay. So to illustrate the use of altimeter setting system, follow a flight from Dallas Love Field, Texas to Abilene Municipal Airport, Texas via Mineral Wells. So these are the flights which will be using the altimeter setting system. They given example. They given us a example here. So before taking off from Love Field, the pilot receives at current altimeter setting of 29.85 from the control tower or automatic terminal information service and set this value in the altimeter setting window. The altimeter indication should then be compared with the known airport elevation of 487 feet. Since most altimeter are not perfectly calibrated, an error may exist. So before taking off your airplane, uh, the pilot will set the altitude value in the altimeter, okay, which will be received from the control room. So most of the time, that altitude value will not be correct. It may have some errors. Okay. See here, this is the altimeter setting value. So altimeter setting value now, while you are taking off your system, the altimeter value setup given by the tower, that is control room, is 29.94. Ana, while you are moving, you will be getting the range, that is altimeter value, altitude value as 29.69. அப்போ இதை ரெண்டையும் difference பண்ணினா 0.25 will be the difference value, which is nothing but error. Okay, error value in the altitude. Okay. இதெல்லாம் ரீட் அவுட் பண்ண வேணாம். யூ ரீட் அவுட். தென் அல்டிமீட்டர் ஆப்ரேஷன் பார்க்கலாம். So there are two means by which the altimeter pointer can be moved. The first is the change in air pressure, while other is an adjustment to the barometric scale. When the airplane climbs or descends, changing pressure within the altimeter case expand or contract. The same point is given here, so no need this also. So due to the changes in the wafer, you will be getting the indication in the altimeter. Okay, so which will be indicating the altitude value of your airplane. Okay, and also the parameters pressure and temperature will give the changes in altitude value. Okay, this is what they given here. The next we come to types of altitude. So types of altitude is uh, indicated altitude, true altitude, absolute altitude, and pressure altitude and density altitude. Okay, so indicated altitude. So five types of altitude: indicated, true, absolute, pressure, and density. Five types of altitudes. So indicated altitude. So that altitude read directly from the altimeter when it is set to the current altimeter setting. So indicated altitude is nothing but current என்ன set பண்ணாங்களோ that will be learnt. It is indicated altitude. Then true altitude. True altitude means the vertical distance of the airplane above sea level, which is actual altitude. It is often expressed as feet above mean sea level. Airport terrain and obstacle elevation on aeronautical chart are true altitudes. So true altitude value will be indicated, will give the true altitude value, which will not give the uncorrected value, because above the mountain or sea level you will be having the changes in the altitude value, so that actual altitude value will be indicated. Okay, so this will give the true altitude value. And then absolute altitude. Absolute altitude means the vertical distance of an airplane above the terrain or above ground level will be called as absolute altitude. Pressure altitude now, the altitude indicated when the altimeter setting window is adjusted to 29.92. So now the barometric scale 29.92 nu set pannina, that will be indicating the pressure altitude type. Okay, ஸோ கரண்ட்டாக செட் பண்ணுறது இண்டிகேட்டட் ஆல்டிடியூட். இது சீ லெவல்லேருந்து உனக்கு இண்டிகேட்டரில் காமிக்குது இல்லையா, அது ட்ரூ ஆல்டிடியூட். இதே ஒரு மவுண்டைன் இல்லைன்னா டெரைன் இது மாதிரி இருக்கிற கேசஸில் காமிக்கிற ஆல்டிடியூட் ஹைட் ஆஃப் த ஏர்பிளேன் வந்து அப்சல்யூட் ஆல்டிடியூட். இதே 29.92ன்னு உன்னோட இண்டிகேட்டரில் காமிச்சிச்சுன்னா தட் வில் பி கால்ட் அஸ் எ ப்ரெஷர் ஆல்டிடியூட். தென் டென்சிட்டி ஆல்டிடியூட். ஸோ இது வந்து பார்த்தீங்கன்னா similar to your pressure altitude it will be indicating, but it will be indicating the altitude based on your temperature changes. Okay, அதனால தான் இதுக்கு பேரு டென்சிட்டி ஆல்டிடியூட்.